All right, let's jump right in. Today, we're going to talk about the one skill that's at the absolute core of every app, every website, all the tech we use every single day. We're talking about the thinking behind the code.
Seriously, think about it. When you see some amazing new app on your phone or a game that looks incredible, how does that even happen? Where do you start? Do you just, pick a language like Python or JavaScript and hope for the best? Well, here's the thing. That's actually not the right question to ask. The real secret isn't learning a specific language. It's about mastering a way of thinking that happens before you even type a single line of code. And that's exactly what we're going to unpack.
Okay, let's really get into what this means. To build anything that lasts, you need a plan, right? An architect would never just show up and start laying bricks. They create a detailed blueprint first. Well, programming is exactly the same.
And that blueprint, that's what we call programming logic. It's the art of taking a huge, messy problem and breaking it down into tiny, simple, logical instructions that a computer can follow perfectly. Because at the end of the day, computers are incredibly powerful, but they just do exactly what we tell them, one step at a time. This logic is, quite literally, the blueprint for your code. So, if programming logic is the blueprint, what's actually written on it? What are the key parts and pieces that make up the whole plan? Let's deconstruct it and take a look. And here's something that might surprise you. Every single piece of complex software out there, from your phone's operating system to the code that flies spaceships, is built from just a handful of simple but really powerful ideas. These are the absolute fundamentals. Think of variables as just labeled boxes for storing different kinds of information. Control flow is how the program makes decisions, using if this, then that logic. And loops just tell the computer to repeat an action. And functions, they're like reusable mini-programs or little recipes that do one specific job, which keeps your code super clean and organized. Getting these three down is the first huge step. Okay, once you can give instructions, you need a system to manage all the information your program is juggling. You need a set of digital filing cabinets, with each one designed for a specific kind of job.
And these are some of the most common filing systems. Arrays and lists are basically like numbered shelves, perfect for keeping things in order so you can grab them instantly. Stacks and queues are all about the order. A stack is like a pile of plates. The last one you put on is the first one you take off. A queue is just like a line at a coffee shop. First in, first out. Honestly, picking the right one of these can make your program run so much faster.
This is where you really level up. You go from just making things that work to making things that work beautifully. With your instructions and your organized data, these are the advanced strategies that let you build software that's fast, efficient, and can handle massive challenges. Yep, these are the power tools. This means mastering clever ways to sort and search through millions of pieces of data in a blink. It also includes really cool, almost mind-bending techniques like recursion, where a function calls itself to solve a smaller piece of the same problem. Kind of like those Russian nesting dolls. Understanding this stuff, that's the difference between building a garden shed and engineering a skyscraper. So, we've seen the blueprint, we've seen the building blocks, but who is this really for? Who is that aspiring architect who needs to master this way of thinking? Let's make this personal for a second. As I go through these, just ask yourself if any of this rings a bell, if it sounds like where you are right now.
See, this is the thing. It's for a whole range of people. If you're a complete beginner, forget the languages for a second. This is your true starting line. If you're a student who's stuck and frustrated, I'm willing to bet this logic is the missing piece of the puzzle. And hey, even if you just love solving problems, this is the ultimate workout for your brain.
Now, you might be wondering if you need to be some kind of math wizard to do this. And the short answer is no. But it does help to come to the table with a couple of key habits already in place. It's really less about what you know and more about how you think.
You definitely don't need advanced calculus, but a handle on basic math is helpful. What's way more important, though, is analytical thinking. That ability to look at a big problem and not freak out, but just break it down into smaller, manageable parts. If you can do that, you have everything you need to start. For real.
So, let's put it all together. We've talked about the blueprint, now let's talk about the finished skyscraper. Where does mastering this logic actually take you? What's the end game? And here's the cool part. Building this foundation doesn't have to take forever. The source material for this explainer suggests that with a focused effort, you can get a really solid command of these core principles in as little as 8 weeks. And this quote just says it all, doesn't it? The real goal isn't a grade on a test. It's about being able to walk into a professional environment and have the confidence to tackle the real projects they give you. That's the target. This is it. This is what it's all about. The ability to take an idea out of your head and turn it into a working, functional, professional piece of software. That's the power that mastering programming logic gives you.
So we've laid out the entire plan, from the basic foundation to the career-ready outcome. The blueprint is right there in your hands. The only question left is, are you ready to pick up the tools and start building?